We will now solve this given differential equation by using the Laplace transform. So first, I'm going to apply Laplace transform to both sides of this equation. So therefore, I write this as Laplace transform of y double prime plus 25y. This equals Laplace transform of 10 times of cos of 5t. Now we apply the linearity property on the left side. And as per the linearity property, we can rewrite this as sum of two Laplace transforms, that is Laplace transform of y double prime plus Laplace transform of 25y, and this equals, since 10 is a constant, we can factor any constant out of the Laplace transforms. So I write this as 10 times of Laplace transform of cos of 5t. Now we will be utilizing this formula to find the Laplace transform of y double prime. So I'm going to use this formula, that is Laplace transform of y double prime equals s squared times of Laplace transform of y minus s times of y of 0 minus y prime of 0. So we have taken the Laplace transform of y double prime. Now let's find the Laplace transform of 25y. So I factor the 25y and then write down only the Laplace transform of y. And this equals, we have 10 times of. We can use this formula to find the Laplace transform of cos of 80. So Laplace transform of cos of 80 is s divided by s squared plus a squared. So here we have a equals 5. So therefore we can write down this as s over s squared plus a is 5. So I put this as 5 squared. Now let's simplify this. We will also apply the initial condition, that is y of 0 is 0 as plus y prime of 0 is also 0. And this means when we apply the initial conditions, this is s squared times of Laplace transform of y. And since y of 0 is 0, we can simply cancel this, as plus y prime of 0 is 0, and so therefore this term is also 0, and so we are left with plus 25 times of Laplace transform of y, and this equals 10 times of s over s squared plus 5 squared. Now we have a common factor, that is Laplace transform of y here as plus Laplace transform of y here. So I'm going to take the Laplace transform of y. I'm going to factor it. So it becomes s squared plus 25, and this equals 10 times of s over s squared plus 5 squared. Now I divide both sides by this expression, that is s squared plus 25. So this will be Laplace transform of y, and this equals 10 times of s over s squared plus 5 squared, which I can write down this as 25 now, and then divided by 1 over s squared plus 25. Now we see that this is binomial. We have the same binomial, so we can rewrite this as 10 times of s divided by s squared plus 25 quantity square. And on the left side, we have Laplace transform of y. And so now to determine the y, we have to take a Laplace inverse on both sides. So I'm going to apply Laplace inverse on both sides. So on the left side, we will have Laplace inverse of Laplace of y. And on the right side, I have the factor 10 as it is, and then take only the Laplace inverse of s over s squared plus 25 quantity square. We know that Laplace inverse and Laplace will get cancelled. That is basically Laplace inverse of a Laplace of a function. We'll have only that function. So here we will have only y, and on the right side we can use the formula to find the Laplace inverse of this expression. That is, this is basically the Laplace inverse formula. I'm going to use this formula. That is, Laplace inverse of s over s squared plus b squared equals 1 by 2b times of t times of sine of bt. So if we apply that formula, we see that instead of b, we have 25. That is, instead of b squared, we have 25. So therefore, b equals 5. So when we apply the formula, it is 1 by 2b. So I put 1 by 2 times of b is 5. And then t times of sine of bt. That is t times of sine of, instead of b, I have to put 5. So it becomes sine of 5t. Now I see that 2 times of 5 is 10. So this 10 and this 10 will get cancelled. And so finally we are left with the expression that is y equals t times of sine of 5t. In fact, we can replace this y as y of t, and this equals t times of sine of 5t. So we find the solution of the given differential equation by using the Laplace transform as well as the initial condition. Therefore, answer choice 2 is correct.